Okay, why does LINQ not stink? Well, because it's so useful. You're actually going to find that you probably like LINQ very much. It's a lot easier and more logical in many ways at first glance than SQL itself, okay? So why LINQ anyway? Well, it allows data selection, manipulation, all the things that we've learned to do in database work, okay, to be programmed right in our .NET application using the language we're using there, C#, right? You'll notice I often reference VB as well because, you know, you can use that for .NET and so on, but we'll just focus on C#. Lots of benefits. For one thing, from the front-end program, the actual .NET application, if you want to put together an SQL command and pass it off to the database, well, of course you can still do that, right? No problem. But you're building it as a string. Strings are very brittle. They break easily, right? You know, think, especially if you're going to be concatenating some substrings together to make the whole command. You know, you got the select, the projection, and where clauses. Maybe you're going to build it in a big string or in parts and put it all together. Well, all it takes is one dumb mistake. You leave out a space between two words, right? Because you're concatenating together. And the whole thing will crash and burn when you pass it off to the database server, right? So yeah, that's a real problem with SQL commands working inside the front-end program, right? You also don't get syntax checking or any validation or anything until, once again, poof, you send it off miles around the earth to the database server for it to be executed. And only then do you find out, oops, okay, I got a little boo-boo in there. Whereas if you had syntax checking as you're typing, you could find it right away. And that's what we get with LINQ, right? IntelliSense as well. It helps you to write your actual query with the IntelliSense and so on. So there are a lot of reasons why LINQ is good that way, right? And it allows us to query more than just database tables as well. Learn the syntax of LINQ and it's applicable all over the place in software development, okay? We're going to be doing a lot of work with LINQ to objects because basically we're going to get collections of objects and we can manipulate them there. So we'll have experience with that. LINQ to SQL is a special flavor of LINQ specifically for working with SQL Server, right? Highly optimized for that situation. There's LINQ to data sets. We can link to just data stored in XML files for that matter, right? As well as many other repositories. LINQ to XSD, parallel link, okay? So if you have a system with parallel processing capability, you can really speed up the effectiveness of queries by spinning it off into different threads. It'll run on in parallel, and then at the end, it all comes together to give you the result much more quickly, right? LINQ to entities, we're going to be touching on that as well. And I feel like the guy selling Ginsu knives. And that's not all. Want more? Woo, look at all these, okay? We can link all kinds of third-party add-ons, okay? LINQ to Amazon, Expressions, Flickr, and you know, this list has been growing and growing. I haven't kept up with it. There's lots of new ones I don't even have on here, right? Anyone heard of Hibernate? Hibernate is an open source object relational mapping system, very popular with certain database systems, and Hibernate is a .NET version of it. Anyway, there's lots and lots of things we can query using LINQ. So bottom line is, I don't want you to memorize any of that stuff. Just be aware that LINQ, once you learn the syntax, is going to be useful to you in many, many situations, right? So what does it come down to? Well, all it is a bunch of standard query operators added to our C# language, right? Or same for VB, but okay. So we use them in addition to the other language elements like lambda expressions, anonymous types, and so on, to just create queries in the native language we're working with. So let's compare, right? Look familiar? Good old SQL. Select, from, where, order by, group by, right? You've learned the hard way that the order by has to come before the group by and things like that. Yeah, there's a syntax to SQL, right? Did you ever, though, notice that often your instructor would say, well, just put select star until you get the from clause in place. Then, when you go back to work on the projection, you don't want everything, you don't want star, but once you've defined the from, you'll actually have some IntelliSense helping you write the code in the select clause, right? That projection. Well, guess what? They kind of thought about that when they came up with LINQ. That's why you'll see the main difference that jumps out to you on the screen here. Again, the top one is VB, kind of ignore that. In the bottom one, we see var, What is var as a keyword in C#, by the way? Yeah, it's a variable, but it's an anonymous type. It'll hold anything. Whatever the right side of the equal sign resolves to, what kind of an object it is or anything else, okay, var will just hold it. It's dynamic. It just becomes whatever you give it, right? Okay, anyway, so that's one of the features we're going to use here with LINQ. But notice on the right side of the equals, the first phrase is from, because they learned from the frustrating experience of all SQL developers that if we define the from clause first, everything else falls in place very easily, right? And select is at the end, right? From, element in collection, where, right? Order by, select, and so on, okay? So it's very similar, and away we go, okay? Quick example, right? Very simple one, we have an array. Very simple kind of collection. One of the easiest collections there is, an array of integers, right? That we've defined called numbers. Then I can do a LINQ query to pull out numbers that are less than or equal to 5 and put them in order. Look how SQL similar it seems, right? I say my var small numbers equals from n, that's my placeholder variable I sometimes call it, in the array numbers, right? Where, there's my where clause. It's a logical expression, true or false, right? Order by, well, just by the placeholder variable. Select n, that's the entire projection is just a number itself. And then once we have that, we can just do a for each loop, go through and regurgitate them all out to the console, and away we go, right? Quick example of a query written in C#, right? Kind of similar in concept to how you might do a query in SQL. Okay, so it does require two of the newer language features that we have. Okay, I mentioned anonymous types, right? Because you never know for sure exactly what you're going to get from a LINQ expression. So using var, well, sometimes you do. And you can use the specific type if you want, but var allows us to get away with that, right? That construct for whatever we want to store there. The other thing is lambda expressions, okay? You've used lambdas before. Have you talked about them much in the other classes? I think they were touched on in one of your C# classes, but the idea of a lambda, it's a, as it says here, anonymous inline function. If you can only remember one thing, just remember the phrase inline function, right? It's like what you did in high school in your math class, y equals f at x, right? So here's an example, okay? The lambda operator often is read as goes to, it's that equal sign with a greater than symbol, okay? So on the left of it, you have basically the, think of it like the parameter you're passing in, and on the right of the goes to is an actual expression. So it's an inline function saying, I'll give you this, do this with it, and give me the result back again, right? So normally it's how we can just then on the fly define a function, so to speak, and then use it, right? That's what a lambda does for us. Now you don't have to. In my code example here on the slide, we're creating a delegate, right? Which is a basically to take this inline function and make it work like an actual, well, function, right? Okay, so here I can say my delegate is equals, notice x goes to x times x. So then when I call my delegate, pass it a value, it returns the result of that inline function, right? So like I said, it's very much like our old y equals f at x approach. But the neat thing about a lambda is we're passing a whole function as a parameter sometimes, right? So it helps us to write our LINQ queries as well. Now, without meaning to be confusing, there are two basic styles to writing LINQ, okay? And that gives us three syntaxes to use because the third one is the combination of the first two. Fancy names, and they'll be on the test, so remember, no, I'm only kidding. I won't be little mean. Query expression syntax, okay, basically is what we've looked at so far, is making it look in code kind of like SQL, right? Extension method is actually something that over time you'll probably migrate to. But you'll probably start off using query expression because it's more familiar. It's more like SQL. So it looks in code kind of like what you've done in the past, okay? Just be aware that in the end, yeah, although query expression is easier to read and learn, looks familiar, everything gets compiled into extension method syntax in the end by the actual interpreter in C#, right? So over time, I find most developers give up on query expression because they just use the extension methods in the end, once you get used to them and so on and so forth, right? But there's nothing wrong. I will always accept the answer done in either syntax. Let's look at some examples to understand what is I'm actually talking about here, right? Okay, so query expression syntax, as I said, the attempt is here to try to make it look kind of like SQL. Main difference is the from clause comes first, right? From identifier in, et cetera, we have let, where, order by, select, and grouping, okay? So there's that basically the same type of example we had before. So this is definitely query expression. That's the syntax we're talking about here, right? To do that same query in extension method, okay, notice the difference. When we go back again, so here we have from, and in, nums, where, order by. By the way, that could all be on one line, okay? But we normally break it out for more readability and so on and so forth. Here, we could do it with extension methods. I could just say nums, that's my source array, right? Dot. I can go dot where. But now, to provide the logic for my where clause, I have to use a lambda. I have to say, hey, if I give you n, that goes to n is less than 5. That's the function we're going to use in line here to decide the logical test of our where clause. So at first you might look at that and go a bit cross-eyed, say, oh, yeah, I like the other, the other way of writing it much better, right? But once you get used to it, it's not so bad. It's entirely up to you. Order by. Now that's weird. Look at that lambda. N goes to n. Well, why not just say order by n, right? Logically, that seems like the better way to do it. But remember, to use extension methods, we have to pass a lambda expression. So basically, when I just want to say n, I have to use the lambda, n goes to n, right? So we're not changing it. It's just, I give you n, you give me n back, but it has to be a lambda, so that's what we have to do. Now notice I'm showing you, the whole thing could be on one line, as shown below, right? I could just say nums.where, pass the lambda for that, dot order by, and away we go. Works just fine, exactly the same. Why would I ever do it the way it's shown in the top half of the slide? Anybody have a thought? What if I want to do a test of my code, but leave out the where clause? I want all the data without filtering it. If it's written the way it is in the top half of the slide, I can just comment out the dot where. It's on a separate line, so I can just put my 2 slashes like I do in C# to make a comment, right? And I can run the code, no problems, and I'll see all the data without the filtering of the where clause, right? I can't do that if I have it all on one line. So that's often why we'll put it in separate lines like this. Of course, the other reason is the darn screen is only so wide. You have a big long LINQ expression. You have to scroll left and right, and it's a real pain. So this way, it gets all vertical, and it's easier to see and read all at once. So anyway, one reason or another, you'll find I usually do the extension methods that way. Okay, all right, query dot syntax. I said we can combine the two, right? So we can start off with a query expression, okay, that SQL looking thing, and then put it in brackets, and then start going dot this, dot that, extension methods applied to the whole thing. And that's really what it comes down to. As long as our query expression returns a IEnumerable, we can do a whole chain of additional methods using the extension methods onto it as well, right? So why would we ever bother? Well, there's some query functionality that is only available through the extension methods. For example, distinct, right? So here, if you look carefully, sorry, it's a little further down on the screen, my array of integers here, there's duplication. There's the number 3 is duplicated twice here, right? It's in there twice. So when I pull nums out, okay, and I do my query from n in nums where n is less than 5, order by n, select n, I will have 3 showing up twice. Yeah, it'll be in order from smallest to biggest by default, right? But it'll be there twice. So if I want to say, no, I don't want any duplication, I can use distinct. Remember that, you used distinct in SQL last term, right? Yeah, you could say select distinct, and if there's any duplication in the output, it would be eliminated and cut down on the amount of data sent, right? Same idea here, but distinct is only available as a standard query operator. You can't use it in the expression method syntax. So this is how we get around that. We wrap the whole query expression in brackets, and then we can do our extension method dot distinct, right? Okay, so that's why we end up with 3. Now, so far, all of our examples have just been simple integers, but LINQ works with complex objects as well, right? So here I have a class defined for contacts. Okay, it's really bugged me that that is in plural. Urgh. Model name should always be singular. Anyway, ignore that. That's bad. I stole this from somebody else and they didn't do it right. Okay, I should have redone it, but I was too lazy. Had a sip of water, sorry. Okay, anyway, so the point is we have a list of objects, right, of a class called contacts. Okay, so probably there's first names and last names and address information and who knows what else, credit limits, who knows, right? Okay, all right, so here's our query from C in contacts, right? There you go. It's a list of complex objects, but we can query it almost the same as if it was simple integers, right? The difference here now is our where clause, where C represents each contact in this collection of contacts, dot state, right? That's the property in the class, right? Matches, or the to equal sign, compares to is how I usually try to remember to read that. WA for Washington State. Sorry, it's American. All right, that's okay. Trump didn't do it, so I'm okay with it. All right. Order by C dot last name. So again, a property of the class. Okay, the contact class, last name, comma, C dot first name. Select C. Nice, simple to read, LINQ query, very SQL friendly looking, right? And then we can just loop through all the contacts in our result, our Q, which was the result that we got back, and away we go. Notice that when we do the right line, we can just choose, okay, the properties we want to show, right, out of the class. Okay, that's query expression. Now to see the same thing done with extension methods is this way. Again, we have our same list of objects based on our model, right? So we just go our list, which is named contacts, dot where, right? Where, but we have to use a lambda expression. So given C, we go to C dot state compares to Washington, right? Order by C dot goes to C dot last name. Then by, order by, then by, how does that work? Well, let me go back for a second. Our order by here in query expression syntax, I just have a comma separated list. I'm going to order first by the contact's last name, then by the contact's first name, right? Seems simple enough, very much like we do it in SQL. With extension methods, though, we only have one order by. We can have as many then bys as we want to follow that, okay? So the first time we want to specify a property to order by, we do that with the dot order by. And then we can have then by this, then by that, then by the other thing, as many as we want, right? So that's the only other difference. So it really is just a matter of getting used to the lambda expressions, right, in order to specify what it is that we're actually using here in terms of the functionality. Other than that, this is exactly equivalent. The output will be the same as the previous slide. Okay. Can we do joins? The good news is yes. Now this is written with query expression, so it actually reads fairly much like SQL, right? From call in call log, so we have two lists of contacts and call log entries, right? Join contact. In contacts on contact.number equals, sorry, call.number equals contact.phone, right? Then we have an order by clause and a select. Notice this is the first time we've seen this. Instead of just returning the actual object, okay, I can create a new anonymous type. I can say select new and just define the properties from whatever classes on either side of the join I want. I can put together into this new type, right? So in the end, my var Q will be a collection of objects of this new type that are made up of the contact's first name, last name, when the call was made, and the call's duration, right? Pulling information from multiple related objects. And then the whole thing is put in brackets because we only want to take the first 5. Remember you did take 5, take 10 in SQL, right? To limit the output to just the first 5 or first 10 or whatever number you wanted to use in SQL. Well, the same effectiveness here, right? So that's not too bad to look at that join done with this syntax. Doing that join in extension method gets kind of weird looking and a little ugly. But here's the good news. I promise you right now, in this course, you will never have to do this, right? Because what we're going to find very quickly is we don't even need to worry about joins for the most part. If we have designed our database properly, so there's a primary and foreign key relationship between two entities, then we're going to find that there's this wonderful operator, SQO, called .include, right? Think department employee again, that very familiar relationship you've done in databases to death over and over again. Well, if we have a department class and an employee class that has the foreign key in it for the department, I can just in my LINQ query say, I'm going to query department dot include employee, or employee dot include department. I can go either way, right? And that way it will just take care of doing the join for me. So don't worry too much about memorizing this code. I just wanted to show you that it is possible to do with extension methods as well. So a few tips, right? You may want to use the query expression syntax at first, right? It's easier to learn, easier to read, nothing wrong with it, go for it, right? If you want to mix extension methods, then go ahead and put them at the end. Keep each part of your query, whether you're using either syntax. Again, keep it on separate lines, then you can comment out a bit at a time. Good for debugging what's going on and so on and so forth, right? If you're using extension method syntax, now this isn't always true, but it's true if you're doing things like link to objects and so on, if they're already in memory, right? The one that expresses the most limiting query method first, okay, if you put that first, right, technically it'll work if you change the order, right? But if you put it first, then it'll be more efficient because it'll actually reduce the number of objects you're working with before going on to the next operator. Just a little tip. You know what, we don't want to spend too much time on this. This is more of an advanced thing. I went back and added it to the PowerPoint slide. Just pointing out that the two syntax don't always give the same thing, query expression. In a case like this where we're using that dot include I was talking about, right? So a patient has an included doctor object, and it also relates to the medical conditions. This is based on that model I've given you as an example for medical office. Don't worry too much about all the includes. The point is, writing it in this syntax, right, returns an INcludable queryable. What the heck is that? Well, it's like a iQueryable, but we're including objects in it, so we actually have to have a comma separated list of all the objects involved. It's just a little bit more complex than what we really, really want. If we rewrite that query in the familiar looking SQL-like query expression syntax from P in, now we'll still use all the same includes, but at the end we just say select P. The difference is we get an iQueryable, a nice simple iQueryable of patient. We don't have to worry about the fact, right, that there's things included in the patient, that I can go to the patient and actually access the doctor that's stored in there, right? Find out the doctor's name from the object that's inside the patient. We don't have to worry about that. My point right now is that it's a simple iQueryable. As long as that's what we have, we can take the initial query and then keep on adding to it. We might decide, well, you know what? We want to filter by this. So we can add a where clause. Oh, you know what? We also want to filter by this other thing. Add another where clause. We can keep building up the query and building it up and building it up, adding order bys and so on before we actually call it to execute, right? So when we get to this in the course, I'm going to refer back to where I talked about it first, right? But don't lose any sleep over this for now, okay? I mentioned at the bottom of the slide, we can always take the extension method approach that was on the previous slide and simply do a dot as no tracking, right? We'll talk more about what that does. It means we just want a read-only copy of the data. Remember we talked about the unit of work pattern? Every time we pull data, we make changes, we want to make sure it's saved back again, right? That's a unit of work. Well, if we get a read-only copy, we don't have to worry about it, right? We just wanted to have it to show to the user. We don't have to worry about making changes. So that's what the as no tracking does, but it also makes it iQueryable. Okay, that's an advanced topic. I probably should have just left it out, but I didn't. All right, so that's a quick introduction.